Hello, my name is Serin Top. I'm a drum ground inspector in the Senegalese Civil Aviation Authority. So, welcome back to this channel. Today, I would like to share with you this presentation related to a visual aid, which is very useful for pilot during the approach. So, it is commonly called Papi, which stands for Precision Approach Path Indicator. It's a visual approach that gives the right slope to the pilot when they are descending. And it consists of 4 units which are located in a wing bar to a certain distance from the threshold. And each of the units, depending on its position, has a certain angle with a horizontal line, and each unit project double beams, like a white beam which is at the upper part and a red one, and the transition between the 2 beams should be or must be very sharp, and in order to give the right information to the pilot. And this transition light gives the angle with the horizontal line. So depending on the position of the unit, the angle varies from 2 degrees 30 minutes of arc to 3 degrees 30 minutes of arc. The unit A is the farthest from the runway. B is the following with 2 degrees 15 minutes. C the third one, 3 degrees 10 minutes, and the last 3 degrees 30 minutes of arc D. So during the approach, when the pilot is slightly high or too high, he or she will see all the unit as white. So the pilot should then pitch down to be at the right slope in order to go to the aiming point. Otherwise, the pilot will land far beyond the aiming point, and the aircraft will not have enough landing distance available to exit safely the runway. So when the aircraft start to descend, the pilot will see 3 white and 1 as red, the nearest runway. So it's still slightly high. So when the pilot is at the right slope, he will see 2 white and 2 red. So this is a picture, a real picture that was taken during a landing phases. So while the pilot is seeing 2 white and 2 red, he must continue that slope and reach directly the aiming point, which is in the touchdown zone. So when the pilot is slightly below, she will see 3 red and 1 white. Okay. And when the pilot see all the lights are red, he will see that that means the aircraft is too low, and he or she must push up to be at the right slope, otherwise he will undershoot the runway and land short. Even the aircraft can touch the floor before the threshold, which is not a good thing. So there is also thing we have to take in account, which is the ILS. When a glide is installed in the aerodrome, so the information received from the glide must be the same that is given by the Papi. The glide is radioelectric that give a signal, deliver a signal, an electrical signal that is received through the antenna and processed on board before being used by the pilot. So when the pilot see the information, correct information given by the Papi to red to white, at the same moment he or she must also have the right information on the CDI, cost deviation indicator, in order to know that there is harmonization between Papi and ILS. And this information should be the same. So to have the harmonization, we can use this formula. I mean, the distance between the eye, the pilot eye, and the antenna divided by the tangent of the theta. Theta is the slope, which is most of the time 3 degrees. So for installation, the wingspan, the Papi wingspan, the wing bar is located to D1 from the threshold, and the nearest unit here is 15 minutes from the runway, and between 2 adjacent units we have 9 meters plus minus 1. And D1 is received, can be calculated through this with this formula, which is the A2V phase, I mean the eye of the pilot, plus the V2 threshold, which is the wheel clearance, the whole divided by the tangent of B, which is the second angle. And these criteria, these characteristics depend on the reference, the aircraft reference. Can depend also on whether the ILS is installed. Here is the situation, the ideal situation when there is no slope at the threshold, and the altitude of the Papi position present is the same with the threshold altitude. Another point very important to take care is the the obstacle protection surface. So because the Papi should be visible, legible and credible. So that's why there is an obstacle protection surface that is set from the threshold here. This distance depends on the code reference, which the code number of the runway. For example, here if you take code number of 3 or 4, we have 60 meters from the threshold where the obstacle protection surface starts, and the inner edge has a length of 300 meters, and we have a divergence left and right of 15% and a whole length of the protection surface of 15 kilometers. So here, for example, so what we saw here is the azimuthal view. So this is the profile view. So that, as you see, the obstacle protection surface is not a horizontal surface. It's a surface that has an elevation angle, which is B minus 0.9 or A minus 0.57. So, for instance, here we have kind of mountain or anyway, an object which penetrates the OCS, obstruction clearance surface. So here, one of the corrective action is to reduce the height or to completely remove the obstacle, or otherwise we can raise also the theta and so on and so on. So if you need more details on the obstacle protection surface, you can you can check on ICAO Annex 14 Volume 1, which deals with aerodrome design operation. Here we have the length of the inner edge. In our case, we have 300 meters here. The distance from the inner edge to the Papi wing bar, which is D1 plus 60 meters for our example. The divergence, which can be also 10%, but in our example that was 15%. And the whole length, which can be 15 meters. And the Papi side angle is A minus 0.57 degrees, which is also B minus 0.9 degrees. So that's it for this presentation. I think that the information was helpful and interesting. So hope that I'll find you next time. Thank you very much indeed.